Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to present to you about pressure vessel between ASME design versus the China standard design. So joining me today is Farah Nashita, Fatina Nabila, Hazika and Putri Nadira. So to start with definition, the pressure vessel is a container designed to hold material at a high pressure. So there's many ways to design the pressure vessel with the ASME standard, ASME alternative design, China standard, German standard, and etc. So the ASME is American Society of Mechanical Engineering, which is they define the pressure vessel as a container to hold gases or liquid at the pressure substantially different from the ambient pressure. So the pressure vessel we are focusing for today is shell, head, nozzle, and support. So the ASME standard focusing on the material design, fabrication, inspection, and testing, markings and reports, overpressure protection, certificate of pressure, the pressure vessel which apply a heating directly or indirectly sources. So the China standard having a different design which comply to the rules and regulation based on the state relevant. So definitely the China standard requires a jurisdiction for the technical supervision regulation for safety of the stationary pressure vessel. So the general requirement in designing a pressure vessel is the qualification and responsibility, general provision of the design, allowable stress, classification and coefficient of weld joints, pressure test, leak test, the structure design requirements of weld joints, and excessive pressure relief device.
Hi, so today for this section we're going to talk about shell pressure vessel in ASME versus China standard. Okay, so we're going to talk about shell first. A primary component that contains the pressure is called the shell. It's either in cylindrical, spherical or conical in shape. Pressure vessel shells in the form of different plates are welded together to form a structure that has a common rotational axis. So this is the example of the cylindrical type of pressure vessel. Okay, so now we're going to talk about the ASME standard in pressure vessel in terms of shell. Okay, so these are the formula for the minimum thickness for different types of shell in cylinder and spherical. Okay, these also are the formulas, but this is only applied if a welded joint factor is involved. So these are the formula in cylinder and spherical shape. Okay, so type of vessel subjected to external pressure, we have two types, which are vessel operated under vacuum, which is the maximum pressure is 1 bar, and then the jacket vessel maximum pressure difference been taken as full jacketed pressure. Okay, so this is the formula for the critical pressure to cause bulking in the open-ended cylinder. Okay, for long tubes, this is the formula, and this one below is the requirement for this long tube. For 9, we neglect the terms 2L over pi d squared in the denominator. The minimum critical pressure occur then the lobe is 2, therefore equation will be simplified as 13.5, and the Poisson's ratio can be taken as 0.3 and substitute in 13.51 become 13.52. Okay, for short closed vessel and long vessel with stiffening ring, the critical pressure will be higher. So we can use this formula, which is we can see in the green box here. Okay, Kc is a function of diameter and thickness of the vessel and the effective L prime between the ends and stiffening rings. Okay, so this is some example of stiffening rings. So L must be higher than LC. If L is higher than LC, the stiffening will not be effective. So arc of roundness for this shell. So any roundness in a shell after fabrication will reduce the ability of the pressure to resist external pressure. A deviation from a true circular cross section equal to the shell thickness will reduce the critical buckling pressure about 50%. Ovality or roundness is measured by, for vessel under external pressure, this should not exceed 1.5%. So this is the how we design for the roundness of the shell in the ASME standard. Okay, so next we're gonna talk about the China standard for shell. Okay, so to determine the pressure or calculation pressure, the following should be considered. There are three specifications for pressure. So first, when a pressure vessel is equipped with an excessive pressure relief device, the design pressure of such pressure should be determined in accordance with the provision in Appendix B in the China standard. And then with regard to vessel containing liquefied gas, if the pressure vessel are equipped with reliable core facilities, then within the specified load coefficient range, the design pressure should be determined on the basis of maximum achievable temperature. And then with regard to external pressure vessels such as vacuum vessel, when determining the calculation pressure, should consider the possible maximum pressure difference between internal pressure and external pressure. Okay, and then this is for the temperature. The temperature must not be lower than the achievable maximum temperature. When the metal temperature of each part of a pressure vessel under working conditions are different, can set up the design temperature of each part separately. So these are the parts separately. And then we can see that the design temperature range should be between 269 degrees C to 900 degrees C. Okay, so these are the table for the allowable stress value of steel materials for in the pressure vessel. Okay, these are the internal pressure vessel, which is hydrostatic test and gas pressure test, or gas and hydrostatic combined test. Okay, so these are the formula for the external pressure vessel. We have also hydrostatic test and gas pressure test, or gas and hydrostatic combined test. Okay, so these are the discharge capacity for pressure vessel, which is 80 is the heat area of vessel. This is for the vertical vessel and this is for the spherical vessel. So we can use these two formulas to determine the area of the vessel. That's all. Thank you.
Hi, my name is Hazkia Johari and I will present about the head of pressure vessel. So this is the vertical pressure vessel. This is the top head and this one is the bottom head. And another one is horizontal pressure vessel. This is the head and this is the other head. First, I will talk about the introduction of head. All the pressure vessels must be closed at the end by heads. Heads are typically curved rather than flat. The reason is that curved configuration are stronger and allow the head to be thinner, lighter and less expensive than flat heads. Head can also be used inside a vessel and are known as intermediate head. Intermediate head are separate section of the pressure vessel to permit different design conditions. Next is the design of thin wall vessel under internal pressure. So head enclosure is divided into two, which are flat plates and form flat heads. And another one is dome head, which is divided into three, which is hemispherical head, ellipsoidal head and also torus spherical head. Okay, so this is the example of flat plate and form flat heads. So the first picture is flange plate. This two picture is welded plate and another two is bolted cover. This is the dome head type, which divided into three: hemispherical, ellipsoidal and torus spherical that I said just now. So for the hemispherical, it is good for high pressure and also higher internal volume. Ellipsoidal is depth is half diameter. It is same thickness as shell and most common type is more than 15 bar. For the torus spherical, it is similar to elliptical but cheaper to fabricate and it is cheapest for pressures less than 15 bar. I'll show you on how to calculate the minimum thickness for flat plate and form flat head. This is the formula that we use. For the flange end, for the diameter less than 0.6 m, CP can be taken as 0.45. And another one is for the flat plate welded, CP we can take as 0.55. For the both type, diameter external is equal to the diameter internal. So to calculate the minimum thickness for dome end, first one is for hemispherical head. The stress in head would then be greater than that in cylindrical section. Thus, optimum thickness ratio is normally taken as 0.6. For the second one is ellipsoidal head. So this is the formula that we use. And toric spherical head, the formula that we use, where CS is that one. Actually, for the ASME standard and China standard calculation, they are the same that I showed just now for the head part. So this is the comparison between national standard in China and also ASME standard for the fourth item, and this is the comparison. For the nozzle part, I will pass it to Puteri Nadira.
Hi, my name is Putri Nandira Binti Ismail. Today I am going to talk about the nozzle. A nozzle is a cylindrical component that penetrates into the shell or head of pressure vessel. Okay, this is the applications of the nozzle. First, attach piping for flow into or out of the vessel. Second, attach instrument connection, for example like level gauge, thermal wells, and pressure gauge. And third one, provide access to the vessel interior at mainway. And the last one, provide for direct attachment of other equipment items, for example like heat exchangers. Okay, this is the schematic diagram for the nozzle. As you can see here, the nozzle is divided into 4 zones. Okay, this is the zone for zone A, this one for zone B, this one for zone C, and this one for zone D. Okay, this table shows the comparison between GB 50251 and ASME 31.8. As you can see here, the allowable stress for zone A for GB 50251 should less or equal to 15, and for the ASME less than or equal to 10. For zone B, less than or equal to 100. For ASME, less than 46. For zone C, okay, for the material, for GB 50251, it is follow API 5L with carbon less than 0.25%, cerium less than 0.5%, sulfur less than 0.035%, and for the phosphorus less than 0.04%. For the ASME B31.8, follow API 5L in old revision. Note that Shell follows ISO 3183 in new revision. Carbon and cerium are modified for sour service. And for the remarks, suggest to limit carbon content, phosphorus, sulfur and cerium as per some oil company standard. Need to meet sour gas requirement. Okay, now for the pipeline valve for GB 50251, it is not sure that GB standard it is equivalent or not with API 6D value, but for ASME B31.8, API 6D is required, and the remarks API 6D is required, site test required to specify in spec. And the last one for the PWHT, both GB 50251 and ASME B31.8, the thickness should more than 32 mm.
Hi, Assalamualaikum. My name is Fatina Bila binti Rahman, and now I would like to present to you about ASME versus China standard for pressure vessel. And now I would like to talk about supports in the pressure vessel. So for ASME standard, for introduction, support is used to bear all the load of pressure vessel, earthquake and wind loads. There are different types of support which are used depending on the size and the orientation of the pressure vessel. It is considered to be the non-pressurized part of the vessel. So this is the type of support. For the first one is saddle support. It is usually used for horizontal drums that's supported at 2 locations. It separates over a large area of the shell to prevent an excessive local stress in the shell at support point. One saddle support is anchored, whereas the other is free to permit unstrained longitudinal thermal expansion of the drum. Next, we go to the skirt support. So usually used for tall vertical cylindrical pressure vessel. A support skirt is a cylindrical shell section that is welded either to the lower portion of the vessel shell or to the bottom head for cylindrical vessels. It is normally long enough to provide enough flexibility so that radial thermal expansion of the shell does not cause high thermal stresses at its joint with the skirt. So next is the leg support, usually used for small vertical drums that welded to lower portion of the shell. Reinforcing pads are welded to the shell first to provide additional local reinforcement and load distribution. And the number of leg depends on the drum size and the load to be carried. And this type of support is also used for spherical pressurized storage vessels. Next is the lug support. This kind of support can be used for vertical pressure vessels. It is typically limited to pressure vessels of small and medium diameter with the range of 1 to 10 feet, and it is also used for moderate height to diameter ratios in the range of 2 to 1 and to 5 to 1. The lugs are typically bolted to horizontal structural members in order to provide stability against overturning loads. Welded joint is related to the support so that it can join together with the supports that we use for the pressure vessel. So for welded joint efficiency and construction categories, strength of welded joint, depends on two types and two things, which is depends on the type of joint and also the quality of the welding. Soundness of welds is checked by visual inspection and by non-destructive testing by radiography. So possible lower strength of a welded joint compared with the virgin plate is usually allowed and calculated by allowable design stress times with welded joint factor J, where J depends on the type of joint and also the amount of radiography required by the design code. So for China standard, from my research, they did not stated details on the requirements of the design of their pressure vessel. So from all that I can say is the consideration that being taken during the design. So the first one is non-pressure components such as racks or skirt support which are directly connected to the vessel, and for loading, direction forces of bearings, base rings, skirt support as well as other types of supporting item. And then for welded joint, the coefficient of a welded joint should be determined on the basis of the welding form of the butt joints and the length ratio of the non-destructive testing. And the last one is vessels connected with external pipeline. The groove and face of the first girth joint of the welded connection, the end face of the first threaded connection joint, and the first sealing surface of any special purpose connector or pipe. Okay, that's all from us. Thank you.